Hi everybody, I'm here today to introduce episode 2 of I've Never Coded Before Help. This is the second episode in the series, and today we're going to be covering variables and a little bit of vectors and how to do some naming of such things. So today will be the first day we actually get into the actual coding itself. But before we do that, we're just going to explain real quick what variables and vectors are. So what is a variable? It's anything that's not a constant or having a fixed pattern. It's liable to change. I just kind of pulled that definition off of the internet. I thought it worked. But how do variables work, right? So let's say we have a is equal to 5 and b is equal to 7. So what is a plus b? Give you a second to think about it, and it's going to be 12, right? Because a is equal to 5 and b is equal to 7. Pretty simple stuff. So a plus b is 12. The variables can also change throughout code. So a variable will keep its most recent called value. So once again, let's say a is equal to 5 and b is equal to 7. Then we have a bunch of other things that happen throughout the code. And then we say, hey, a is actually equal to 10 now. So then what is a plus b? Well, it's going to be 17 because a has been, I guess, reclassified or reintroduced as a new value here, right? So if you don't want it to be that, you can't have two variables named the same thing, right? So that's why you can have them named lots of different things. So there's several types of variables that I'm going to talk about in this, and they're basically the main ones, which are integers, floats, bools or booleans, and strings, right? So those are definitely your main four that you'll be working with. There are some others out there like doubles, and you can kind of go into bytes, stuff like that. But we're just going to focus on these four because these can do just about everything you need. So I'll introduce each one real quick. So an integer is just a whole number, right? So everybody's always scared by the term integer. It just means a whole number, right? So as I did there, 1, 3, 5, 50. It's negative numbers 2, negative 156, negative 965. At least in Godot, that's how it works. And so an example of this is like my age, right? So my age is equal to 25. So that'd be like an integer, right? So it's not going to be like some decimal number. Which brings us to our next thing, which are floats, which is a fancy way for saying decimal, right? So you want a decimal number at all, you're going to use a float. And a float's can be like 1.52, 6.3, that's 689.235642. And floats usually go to the 7th decimal place. In Python, it's not always the case, but just kind of a general rule of thumb, that's what they'll go to. So an example of this can be like your weight, right? So you're not going to generally be exactly right on 190 in my case. So I'm like 190.45 or 4/10 of a pound, right? So that's really what a float is. And then booleans. Bools are just really a true or false statement. So if you plug in something and ask it for a bool, 0 is for false and 1 is for true. They used a lot in loops, which we'll get to later. That's really what they are, right? So in this, I'm a male, right? So if I say I'm a male, that is equal to 1, which is true, right? Because it's a true statement. And then we get to strings, which are letters with an asterisk. So it's not really a letter. It's just something that's not, I guess, identified as a number. You can't really add strings together, right? You can't like add like hello plus like how are you doing today, right? I mean, you can actually put strings together, but they're not like adding them, right? So a string is, use the little parentheses here, and it's like hello. Or you can actually have numbers in a string, right? So it's 1, 2, 3. But if you have 1, 2, 3, and you try to add, let's say 1, 2, 3 plus like 5, it's just going to error, right? Because that doesn't make any sense. It doesn't view this as a number. It just views it as like basically a word, the word 123. And then here's another example, just how are you today, right? So this is strings. It's how you like print things out, which we'll get to today too. So those are just the four main examples of the big things of variables. And then vectors. So in Godot, they have what are called vectors, which are useful, obviously. And you have vector 2s and vector 3s. So a vector 2 is just like an XY coordinate, right? So it's just a 2D plane, like 2D games, right? You don't have like depth in them, really. So, right? So you just go left or right or up and down, right? So, 2D game, like if you ever played, Terraria or any sort of side scroller, like I guess the original Street Fighter, stuff like that, right? No depth. Vector 3s has an X, Y, and Z coordinate, which is used in like 3D games. Like you're gonna have like Skyrim, Call of Duty, whatever, right? Basically every game that's come out pretty recently uses 3D games, and even some games that look 2D actually use 3D coordinate systems because they can do some clever camera work and lighting that actually makes the game look better. But that's basically what it is. You have an XY coordinate for vector 2s and an X, Y, and Z for vector 3s. And finally, for this little slideshow, we have commenting and naming. So when you comment a code, you're going to use a £, or hashtag, as people say. And we'll show that in a second. But one thing I always want to do, people are horrible at commenting their code. And I'm not saying I'm somebody who's great at it, but I always try to make sure I comment a lot, right? So you think, oh, I know what my code's doing, I don't need to worry about it, blah, blah, blah. And then you write all this code and you think you have it down, and you could just come back to it 2 days later and you'll be thinking, like, what happened here? Like, what is happening in this code, right? And especially if you're having somebody else look at your code, you want somebody to understand what's happening. So commenting is basically just explaining what your code is going to do. So at the beginning of your code, you always want to explain what it's going to do, right? So if your code is going to make your player move, right, you're going to comment at the very beginning of your code, hey, this code is going to make my character move left and right using the WASD keys. Cool. That's your intro code. And then you go down and you comment different sections of your code. And as I already said, it's better to comment too much than too little. Just helps people out. And really a side note with that is an example of how commenting can bite you, at least in the professional sense, is I had a buddy of mine who had an internship as a software engineer. And he was given 10,000 lines of code written in the 90s. This was 2 or 3 years ago. And it was in Fortran. And they said, hey, over the next 8 weeks, none of this code has been commented at all, and nobody has touched it in 20 some years. And nobody knows what it does. And your goal is to figure out really what each part of this does and comment almost every single line of this code. So he spent the next 8 weeks commenting every single line of that code because the people who originally wrote it were no longer around. So that is why commenting can be nice, just in the professional world, because it lets other people know that maybe using your work later on, what's going on, right? And lastly, we have naming variables. So this is another thing people don't do great, is they don't really make sense when they name their variables, which you want them to, right? So my A is equal to 5, B is equal to 7. Earlier is not the best name for that. So like X equals 25, right? So you don't know what that 25 is. And you can have a comment above that kind of explains it, but you might be thinking, what is X? Like, what is this value? But if I say my age is equal to 25, instantly you're going to think, oh, so that means his age is 25. You don't have to worry about wondering what this value is. So it just makes everything easier when you make your variables make sense, right? And also, you capitalize the start of new words. It's generally good coding practice. So if you have like my age, you don't want to have this lowercase a here. You want to be able to capitalize each new word, right? So my age, or if you have some other longer variable name, you can also use, you can't use spaces in code, but you can use a little underslash, and that can kind of create a space. So that's really what I wanted to show there. And so we're going to actually open up Godot today, and we're going to do some basic coding of what we just covered, right? So first with the variables, we're going to open up Godot, and I assume you already have this downloaded, and we're going to create a new project. Let's call it test, and we need to create a new folder, which is just going to be project path, which is going to be some sort of test. Cool. And it's we're just going to use the left one here, the OpenGL, and we're going to create and edit it. So this is going to pull up the game engine itself, and we're not really going to code a whole lot today. We're just going to kind of introduce it, right? So we're just going to click on a 3D scene, and we're just going to do this code right here, right? So we're just going to click attach new script, and we want this default spatial GDScript, and we're just going to explain some things, right? So here's a little example of what they have, which is kind of what I already showed. Variables are declared, and you can kind of just delete all this here. We'll get rid of that, and we'll just get rid of here, right? So what we want to do first is explain what this code is. So obviously you want to start at the top, and you want to be, we're going to comment, say, this code is a tutorial in the series explaining how to code, right? I spelled explaining wrong. Regardless, this is not the best example of explain what your code is, but you understand the point, right? So we're gonna start coding here. So what this says is it extends spatial. So that means this node right here, which is basically a object, right? So this spatial scene right here, right? this guy has a script attached to him. So it's basically saying this is now having some sort of commands given to it, right? So it's extending that value or that node out. And before your functions are where you want to declare your variables, right? So this is saying function on ready. We'll explain function is ready. So basically all you need to know is when we click play, it'll execute everything between function ready and pass. And pass just means skip everything else, right? So if we basically don't have anything after this, it'll just ignore, right? Until a new function is called. So to declare a variable, you just want to type var, right? var. So that means this is going to be a variable. So let's say variable, and we'll call it number, right? We'll call it lower number, number. And we'll call that is equal to 5. And then we will say the second variable is higher number. And that is equal to 7, as we kind of showed earlier, right? And as you can see, there's no red line, so that means we are okay. And then we want to say, we'll just declare one more thing, and we'll say the variable total is a value, right? So basically total doesn't have a value assigned to it, but higher number is equal to 7 and lower number is equal to 5, right? So now down here we can do total is equal to lower number. This will actually pop up if you start typing it. You just type in higher and then click enter. It'll fill it out for you. And so that means total is then equal to the lower number plus the higher number. So what it is saying is 5 plus 7 is equal to 12, right? So total should give us the value 12. And how we can check our answer is pretty easy, right? Just do print, parentheses, total, which we have to make sure our capitalization is right. And print will just print it out to this output down here, right? So if you ever want to test something, print's usually the best way to do it, right? To see if something's working. So then we just run our little game here. You want to save it? Yes, save, it doesn't matter. And running it, we should get 12, and we do. See right here, 12. And we can just ignore that scene for now. That's what we wanted, right? So now we're just going to explain how to use integers and floats, right? So how a lot of this works is by default, the variables, I believe, are floats. So you can have like 5.75 plus 7.63. And then if we rerun this, quick save it, and rerun it, we should get what that new value is, which is going to be 13.38, right? So we get this value we wanted, right? But let's say we want to make it an integer, which this, I'm not sure how super prevalent this is with Godot, but in actual coding, this is a super important concept, right? So especially with things like optimization, which are some of the most demanding things you can use for a computer, right? Because it uses something called n factorial math, which is a factorial is basically, let's say you have 5 factorial. That means 5 times 4 times 3 times 2 times 1, right? And if you have 20 factorial, or 20, factorial is explained by an exclamation mark, or 20 factorials, 20 times 19 times 18 times 17, all the way to 1, right? So very big numbers, and they increase, very fast, right? And so we're doing things like optimization, which use factorials. You'll very quickly figure out that you're using a lot of your computer, right? So if you can use integers rather than, let's say, floats, you're going to save a lot of computational power, right? Because an integer is just one, basically a single value, right? So an integer is like, as we said earlier, just like a 5, right? Versus a float, which would save it as 5.123456 values. So see how it has all this extra space? And you may not think it's a lot, but when this computer is running millions of calculations, trying to do specific tasks, that adds up really quickly. That's one of the simplest way to make your program run faster is just to get rid of floats or doubles or integers and make sure you're doing the right thing. Just a good coding practice to get into in general. So if we do want to do an integer, you're basically going to call it as such as, whoops, it's going to be variable lower number, integer is equal to 5, right? So variable lower number integer is equal to 5, right? So what we want to do here is we want to change how this looks right now. So look how it's kind of awkward, like it doesn't really make any sense, right? So it's saying variable enter 5. So what we want to do is we're going to look at the example, right? Because I can't exactly remember off the top of my head right now which one integer is. So we're going to look, and integer is going to be on right here, which is a colon, right? So pulling this back up, we have lower number, integer is equal to 5. So sorry for that confusion, but basically we have this value now, right? So whoops. So if you want to do a integer, you use just a little colon here, right? And so if we do 5 plus 7, we should once again get the expected value should be 12, but I'm going to show you something. So if we do 5.4, right? And then we try to add it. So normally it would give us 12.4, right? But since we are using integers, it doesn't. It rounds it to the nearest whole integer, right? So that's 12. If we do 5.8, we run it again, we should get 13 from my understanding. Oh, 12. Okay, so Godot actually floors any value. So what that means is it floors it. So if it's 12.8, automatically runs down to 12, no matter what the value is, right? So it'll floor any value. You can actually change that using the floor and seal function, but we won't worry about that, right? So this is why integers are not always the greatest, because sometimes you need decimals, right? And so if we want that to be a decimal, we'll change this to a float, and then we'll add them together, and we should get our value of 12.8. 12.8, right? And we can also use the same thing for bools. So if we want to do a variable of true, and if I can spell it, and we want this to be a bool is equal to 1. You can basically test the same thing, right? And a bool, I don't really want to test it right now because we kind of need an if statement for it, but it's basically a true or false function, right? So we're going to do a string right now. So we'll say variable words is equal to some string, right? So hello, how are you? Nice. So we'll print out total, which is that 12.8 value, and then we will also print out, and we print it out, we should get two different answers. One should be 12.8, and one should be hello, how are you? And there we go, 12.8, hello, how are you? You can also, if you want, you don't actually need a variable here because this is just a variable, right? You can actually just make this like 5, and I'll print out 5, and we can make this hi, right? And it should give us the same value. And I'm giving it a second to pull up, and there we go, we get 5 and get hi, right? So this is really all I'm going to cover in today's video, and it's pretty boring. This is the very fundamentals, but next video we should get into more how to actually do a little more game mechanic things. I feel like there's a lot of examples online on how to use Godot engine, how to make games with it. I just feel like a lot of people don't explain exactly how code works. So that's kind of my goal here, is to do a very simple tutorial on basically the fundamentals of coding, so you can watch other people's series and actually learn a lot more. So I'm just basically giving the very fundamentals, the foundation of it, and then everybody else is going to learn everything, right? So that's the goal of this. So that's the end of this episode, and next time we'll be talking about, I believe, some if statements, and we'll kind of cover what those are and how they work. So thanks for watching.